Hi everyone, welcome to Manish IT. This is Manish. Today I am going to discuss about singly linked list and its implementation part. Before going to discussion, I am telling you very clearly. If you are not knowing about what is linked list, how to represent linked list, and what is node, then please first see introduction part of linked list. Then you will understand in this video. I have also posted the link of introduction part in the description box. Go through that. Now, first thing is what is single linked list? So see, a node contains two fields. One is data field and another is link field, which stores address of next node. Next is it allows traversing in one direction through the elements. Next is it requires less memory as it stores and only one address. So and next is head pointer always points to base address of first node, and the link part of last node is initialized with null. So these all points we have to know it before implementation. So next, what are the operations which are performed in single linked list? See one by one. So first operation is add at beginning, then add at end, then add at a specific position, delete of node first node, deletion at a specific position, deletion at length of linked list, and display of node data and reverse of linked list. These all are operations which are performed on single linked list, and many more operations are there. So now we are going to implementation part of singly linked list. Before implementation part, you should also know what is dynamic memory creations and how it works, as well as you should knowledge of pointer structure with their property and how it works. So let us start our topic. First, I am going to tell about how to create a linked list and brief information about dynamic creation of memory, that is malloc function. So see, this is here I did not write any header file, just started from structure part, that is a struct part. I will show you its implementation and run the program at the end of video. So see here, I have declared a struct node. Node is nothing but it is a variable of a struct type. Inside a struct node variable, I have declared two part. One is data part which is integer type, and another is a struct node type pointer, that is link, which is pointer type variable. So here question is that why I have only declared two part inside this structure, so struct node variable. Then answer is we have already see in this representation of linked list, they are having two part, one is data and another is link part. That's why here I have declared only two variables. And next, here our node declaration is over. Now we have to declare another variable, that is also a struct node type, that is head, and in the beginning head is initialized with null. It is globally declaration because of we have to need this head pointer so many times within our program. So see, now whenever this head pointer is created, then one memory block is created for head pointer and initialized with null. Now see definition part of create function. So this create function having no return value, that's why its return type is void. So inside create function I have declared one another variable of struct node type, that is temp. Why I need to create this variable, I will tell you. Now see, we know that dynamically creation of memory from linked list property. that is malloc function. So I have written here malloc size of struct node. So, struct node. Then here why I have written struct node, because of size of property we have to pass our variable. So now we know that malloc function returns void pointer, then our variable is what? So struct node, our variable is like a struct node type, because of we have to create our linked list, so we need to node. So our main variable is struct node type. So then struct node type, then we have to typecast void pointer into struct node pointer. So see this, how it's looking like. So after typecasting, now this is stored in temp variable. That's why we need to create this another pointer variable. Whenever this temp variable is created, at the same time memory block has allocated. And here we have initialized malloc function in temp, and our malloc function type is struct node type. That means it's having data part as well as link part. Then memory block has created allocated like this. And now we have to pass a message to user, enter the value, and that value read by a scanf function, and enter that value printed to using printf function, and read that value using a scanf function. Now user has entered a value like 10. So suppose their memory address is 1000. So accordingly to our logic, a base address has stored in temp. So now temp is pointed to base address of node. So now in this link part we have to initialize it with null, and head is initialized with temp. So see this, our link part is initialized with null, and head is pointing to here. So we have to replace this null as base address of our node. So after replacing it, it is start pointing to our base address. So now next is add at the beginning. So how we can add at beginning? So see this, how we can write our logic. So here our function is add at beginning. So it's having also nothing return value. That's why its return type is void. So here I have created one like a struct node type pointer, that is name, that pointer name is temp. Pointer variable is temp. So in that temp variable we are initializing like malloc function. So we are called this malloc function. Then whenever this initialization is done, when suppose whenever this temp is called, then suppose before this, what is this meaning? Add at beginning means we having some node, already we having some node. That's why we have to add at first. So that's why we suppose we having like a node, and its head pointer is I already told you, head is always pointed to its base address. So it's we having already a node. So here whenever a struct node temp variable is our compiler to read it, then one another temp variable is created. See this, and in that temp variable what can do? So it is initialized, it is called initialized with malloc function. So malloc function is nothing but it returns node type pointer. So inside node type we having like a data part and link part. So one data part and link part memory is allocated, and after a user has entered some value, then like 10, and their base address is pointed to temporary variable, because of its initialization of malloc function is inside temp. So that's why it's start pointing to its the temp variable is a start pointing to this base address of new node. So this node, we have to check our condition. Our head pointer is equal to null. So if our head pointer is this condition is satisfied, then simply it's printing like this: linked list is underflow. and head is equal to temp. So otherwise here condition is what, our link head pointer having some value like it's pointing and its base address is like head is 2000. So 2000 is equals to null, or can if condition is failed, so it's come to else part and executed here. So in the else part we have written like temp to link, that is temp to link is in a slide with head. So where is temp to link? Temp to link is nothing but this one, null. So we are initializing this as a head. Head is what, our 2000. So 2000 is in a slide here, then it's looking like this. See, 2000 is in slide, then head is equals to temp. So our head is what, head is 2000 and its temp is what, so 1000. So head is nothing but it is a variable, so 1000. Now our head value before head value is 2000. After this statement it's replacing by 1000 and pointed to like here. So see this by mistake here 1000 is happening, but by mistake it's pointing to 2000. So now we have to free our memory block. Then after free this block it's looking like this. So see, it's how we next, our next function is add at end. So whenever it's this function add at end function, also return type is zero, sorry, void. So void, and it's having also three type like add at end means what, we having already node, and we have to add add a new node in the last. So see this, we having suppose we having node like 20, 30 and 40 and new node added here. So how to write and how to traverse here. So see this, first we have to create a local variable, local pointer type, struct node type pointer, that pointer like temporary pointer and p and q. So why I have created here three type pointer, I will tell you. First see this how it's happening. So here I have written like int length and I equals to 1. So whenever this struct node our compiler comes here and read this value, then a memory block is created like p, then temp and then q. So see this our memory block has been created. So our next line is executed like int length and I equals to 1. So our next line p equals to head. So here is p block, p is equals to head is nothing but 2000. So it start pointing to its base address. So see this how it's looking. So to p having 2000 because of we already initialized head inside p, so it starts pointing to base address. So see this, and temp one another pointer, we have to add one node, so we have to create a node. So that node is initialized in temp variable. So temp node is created, and some value has user has some entered some value like that is 50, and their address is 5000. So that 5000 address is initialized in this temp area. So after initialization it is start pointing to its new base address of new node. So here one length function I have called here. So in next slide I will discuss this length function. So length function, here length function is nothing but it's counting the node, how many nodes are present before adding this. So before addition of new node we having our we have node like 1 2 3. So our node length is 3. So this length function returns 3. So here inside len value variable it stores 3. So while we are, our compiler comes to while condition and checking I is already initialized with 1 and length function is 3. Our length of no linked list is 3. So 3 minus 1, that is 2. So 1 is less than 2. Condition satisfied. then inside a while loop, our compiler come to inside while loop and executed these all lines. So p equals to p2 line, p2 link is nothing, where p2 link is 3000. So here inside this p stores 3000 because of p equals to p2 link. So p2 link is 3000, and our new value of p is 3000. So it's a stop pointing here and a start pointing here. So see how it's looking like this. So start pointing here. Now I is incremented by 1, so 1 it becomes 2, 2 is less than 2, condition fail. So it exists from while loop and executed this line, q equals to p2 link. So p2 link is what p2 link means 4000. So it stores in q here, 4000 stores, so it start pointing to this one. So see this how it's looking. So after it's now it's pointing to its base, like 4000. So now our next instruction is q2 link equals to temp. So here is q2 link, q2 link is null. So null is initialized with temp is nothing but 5000. So 5000 here initialized. So after initialization, how it's looking like, see after 5000 it is pointing to here because of we already see this initialization and correlation in between node in the introduction part. So after storing this 5000, it is pointing to and related to here. So next we have to our compiler comes to this area. So whatever local variable is created, that is automatically deleted from our program. So our local variable temp, p, q, these all are deleted, but global variable never deleted after closing function. So here our globally head is our global variable, so that's why it's not deleted, and its address stores like 2000. So these all things are deleted. So after the deletion, how to verify our this program? So see this verification by calculation. In the starting, p is initialized with head is nothing but 2000. So p equals to 2000, temp equals to 5000 because of temp having a struct node type. So temp is a start store point. Temp is nothing but it stores base address of new node, so it is having 5000. So 5000 length is nothing but 1 2 3. So 3 is length, and it's checking condition 1 is less than 2, condition satisfied, then exist, then enter to while loop. And while loop, p equals to p2 link. P2 link is nothing but 3000. So 3000 stores in p. So now our new p value is changed with 2000 to 3000. So p new p is equals to 3000. I incremented, then I equals to 2. So 2 less than 2, condition fail, then exist from while loop. And q equals to p2 link. P2 link is nothing but 4000. So 4000 stores in q. So here q2 link. So q2 link is nothing but null. Before we saw that here null is pointed here. So that is equals to temp is nothing but 5000. So q2 link area is 5000. So it starts pointing to here. So this is the logical our program. Here this is the program, and its verification by calculation. So next is length of linked list. Because of we already called this length function just before slide. So see this int, because why I have written here int, because of it's returning some value. So that's why its type return type is integer type. So here I have created one integer that type variable, that is count, and count is initialized with 0. So here our compiler comes to struct node part. So int length linked list means we having uh, some node. So see, suppose we having some linked list. So these are linked list. So suppose see this. struct node temp variable. So temp, whenever temp variable is called, then one memory block is created for temp. So see, this temp is created, and that is in a slide with head. So head is nothing but 2000. So but here by mistake, 2000 here is 1000. So it is in a slide with 1000. So 1000, whenever temp is in a slide with this base address, then it starts pointing to here. So see this. Now condition is that whenever if you having nothing linked list, then we our whenever you call this length function, then that times we it's printing like linked list is underflow. So when temp equals to null, that means temp what is temp already initialized with head. So temp is nothing but head, so head is equals to null. So here temp is 1000. So here condition, if condition is fail, now it's our compiler comes to else part. So else part having while temp is not equals to null. So then it enter in while loop and executed all these lines. So see here, temp is 1000. So 1000 and you can also check here condition like temp is equals to head, that is 1000, while 1000 is not equal to null. So condition satisfied, and enter inside while loop, and count is incremented by 1 means count equals to 1, because of already we having count is 0. So count now count becomes 1. So temp equals to null, because of here temp equals to temp to link. Temp to link means 2000. 2000 stores our temp new temp value is 2000. So here once again we have to check our while condition, because of while condition, whenever this condition is whenever this condition is failed, then we exist from this loop and also else part, then our compiler comes to return part. But our condition, how many times our condition is satisfied, then we enter this while loop and executed all these lines. So once again our temp value is 2000 becomes 2000. So 2000 is not equal to null, condition satisfied. So count is incremented, count becomes 2, and temp equals to temp to link. So see how this happening. So after increment, temp to pointing to 2000. So it's like it becomes once again our temp count is 2, then temp equals to temp to link, that becomes 3000. So it's a start pointing to here. So once again while 3000 is not equal to null, so a condition satisfied, and count is incremented by 1. So our count value is 3. So here see this, after incrementation our temp is equals to temp to link. So temp to link means 4000. So inside temp value it becomes like 4000. So see this, after 4000 it's start pointing to here. So now once again it's check like count is in incremented by 1, and that means count equals to 4, and temp equals to temp to link. So here temp to link what, null. So our new temp value is null. So while null is not equal to null, condition fail, exit from this loop and returning only count value. What is count value? That is 4. So now our length is 4. So it's returning simply 4. Whenever this length function is called, then in for this linked part is showing like 4, linked list linked length is 4. So during running time you can also observe these all things. So these are calculation part. And next see this, our whenever our this the temp is locally created, so it's deleted. So see this, add after a specific position. So it means what? After a specific position means you having already any node. So see this, suppose you having a node like this, and you want to add any uh, a specific position. So suppose you want to add third location. So whenever our compiler comes to here int location, location variable is created and I is initialized with 1. And here struct node is nothing but it is a temp and a temporary temp type pointer variable, and it initialized with head. So it is giving a message to user and taking read that value by scanf, and once again length equals to length function. So len variable is called length function. So it's counting our length 1 2 3 4 5. So 5 is initialized here in len function. So condition, we have to check if location is greater than length. Suppose user has entered some extra location. Suppose our length is 5 and user has entered 6. So in that condition, it's showing like invalid location. Your link delete length is whatever length is here, that length is printed like this. So if this if condition is failed, then else part executed. So here if condition is failed, because of we having already node, so else part is how we write. So here we having a struct node and p type variable and q type variable. So in the starting, temp is pointing to head. So here p and q, two types of print pointer variables. So it's create a memory location. So it's like, see this. So p is nothing but it is called malloc function, and that is a struct node type. So that's why data part and link part. So one q, because of we having already a struct node type, so q is also created a memory block. So now user has entered some value like this 15. So its base address is 1500. So suppose after p stores 1500 and start pointing to its new node base address. So see this, and a link part is initialized with null. So we have to check our condition while I is less than location minus 1. So I want to add in the third location. So third 3 minus 1, that is equal to 2, and I already 1 initialized with 1. So 1 is less than 2, condition satisfied. So it enters inside this while loop and executed this line, temp equals to temp to link. So temp to link is nothing but 1000. So 1000 stores in temp variable, and I is incremented. So once again 2 is less than 2, condition fail. So it's stop point exists from this while loop and come to here. So we having already temp variable stores like 1000 and start pointing to here. So now q stores temp to link. So temp to link is nothing but 2000. So here q having 2000. So now p2 link equals to q. P2 link is what? So here p2 we having created p2 link is null. So we have to initialize with q. So q is what? 2000. So before it's in pointing to here, so q having 2000. So when this null area becomes 2000, so it's pointing to here. So see this, after storing this 2000, it's start pointing here, and next line executed temp to link equals to p. So where is temp to link? Temp to link is 2000, and whenever initialized with p, so that means 1500. So instead of 2000, it's looking stores 1500. So it's start pointing to here. So this node this link part is deleted from here, and it's creating a new linking part from this. So see this, how it's looking like. So after it storing, whenever when it stores 1500 base address of new node, so it's start pointing to this, and it exists. So our addition of new node is add after a specific position is successfully. So see this, how it's after we have to free all these things are local variables. So after free all these local things, how it's looking like this. So see our new node linked linked length linked list is looking like this. So next, see, verification by calculation. Temp equals to nothing but 0600, and location is third location, and length is 5. So when 3 is greater than 5, condition satisfied and goes to else part. So p is equals to 1500. So already I told you. So while 1 is less than condition satisfied, then enter inside loop, and temp equals to temp to link, that is 1000, and I is incremented, then I becomes 2. So I becomes 2, while 2 is less than uh, 2, condition fail, then exist from while loop, and q is equal initialized with 2000. So here P2 link is nothing but it stores 2000 because of Q value. So, and next one is temp2 link is 1500. So it's create a, it's start pointing here. So question is that why we have to initialize from left side, why not from right side? So see, whenever you are linking this part, then from this part, it's first it's stop this linking area, and whenever it stops this linking part, so it we our uh, bond between these nodes are broken, then we cannot traverse from one node to another node. So due to this reason, we have to always linking we have to link from left side to right side. So that's why left to right, sorry, right to left, we have to follow right to left. So we have to first connecting our link area, then we have to our address, base address of another way. So right to left, we have to follow right to left. So next is delete at a specific location. So its meaning is like we having some node, and we want to delete some like 20, 10, 30, 40, like that. So here we are called a delete function, that that is nothing returning any value. So that's why it's a void return type. And when we are calling like a struct node temp, so temp is created a block, and that is stores head. So it stores like 0600 and starts pointing this base address. So now location and length and integer, these all variable are created integer types. So we give a message to user, enter location to delete, which user which location want to delete. So suppose user has entered some location, and length function called. So once again location is if suppose user has entered this location. So once again it's a checking condition. If location is greater than length, then printf function is whatever statement written in there, that executed. But if condition is failed, then it's executed else part. And else part, suppose here like a struct node p. So p is whenever it's called, then like it's come to p block is created. So see, we have to delete like suppose a user want here user has entered like third position, want to delete this part. So 3 is minus 1, that is 2. So 1 is less than 2, that condition set attempt to the condition satisfied, and temp to link uh, temp equals to temp to link. So temp to link is nothing but 1000. So that's why it's stored 1000 and starts pointing to this base address, and I is incremented by 1. So I want 2 is less than 2, condition fail. So it's exists from while loop, and comes to this line. Our compiler comes to this line. So p equals to temp to link. So temp to link, now temp to link is to 2000. So that's here p is pointing to this 2000. So see this stores, and it starts pointing to 2000. Now temp to link equals to p2 link. So temp to link is what? Temp to link is 2000. So it's and p2 link is what? So p2 link is 3000. So now it's replaced by 3000. So and after replacing, see, after replacing, it's pointing to here, it's start pointing to here. So how it's looking like this, so see this. So it's this link part is broken. So after broken, p2 link equals to null. So p2 link is 3000. So this 3000 is replaced by null. So see this how. So after null, then it's stop pointing to this. So after stop pointing, it's deleted. So see how we can check it by calculation part. So when location is user has entered location 3 and 3 is greater than 5, so no if condition is not satisfied and exist from if condition and executed else part. So while I one I because of I have already I is equals to 1, so 1 is less than 2. So here location minus 1, that means 3 minus 1, that equal to 2. So temp equals to 1000, so 1000 and I becomes 2 after an increment. So 2 is less than 2, condition fail, exist from loop, and p stores to 2000. So here 2000 and temp to link is nothing but 3000. So it's 3000 and p2 link is null. So it's null, so it's a stop pointing and it's free. So see how it's looking like this. So after a local after completing this void function, void delete function, so it's our compiler comes to here. So all local variable automatically has been deleted. So see, next function is delete at the first our last node. So first how to delete this first node. So see this void delete first. So struct node temp equals to head. So temp is created and that is initialized with head, that is 1000. So 1000 is initialized here. So head equals to temp to link. So temp to link was what? So temp to link is 2000. So it is stores in head. So whenever head equals to, now head, our head is becomes 2000, so it's start pointing here. So see this whenever temp to link is 2000, so it's stop pointing here and start pointing here. Now temp to link equals to null. So temp to link is what? Temp to link is 2000, so it's become null. So see this, when it's null, then it's a stop pointing. So after stop pointing, it is deleted. So see this, after deletion, our linked part is looking like this. So now next is how to delete last node. So delete last function is called and it returns void type, that is 0 null type. So struct node and temporary variable created and temp is stores head. So head is nothing but 2000 and it's pointing to this base address. So now length variable and I equals to 1. So length function is called and initialized in len variable. So now while inside while condition we have written like 1 is less than suppose in last length is 3 and I want to delete last node. So 3 minus 1 2. So inside condition is satisfied, 1 is less than 2, condition satisfied. So it's in a slide temp equals to temp to link. So temp to link is nothing but 3000. So inside temp it store 3000 and start pointing here. So it's start pointing here and I incremented by 1. So 2 is less than 2, condition fail, it exists from this loop and come to this part. So temp to link equals to null. So what is temp to link? Temp to link is 4000. So when it is initialized with null, so stop pointing. So see this, after initialization of null, it's stop pointing. So its linking part is disconnected. So it means it is deleted. So see this, after linking part is disconnected, so our node is looking like this. So next is display all the data. How to display function is called. So struct node temp. So temp is temp memory allocated and it is initialized with head. So head is nothing but 0600 and condition check if temp equals to null. So temp is not equals to null, so condition fail. If condition fail, then else part executed. So simply it's printing like elements stored in the linked list. So see, first it's like pointing to base address, so print %d and temp2 data. Temp2 data is what? So temp and data is 5, so it's printing in the on the console screen. So first it's printed as element stored in the linked list, whatever I have written here. So it is executed and its temp2 data is 5, so 5 is printed here. First 5 printed, then it stores temp equals to temp2 link. So temp2 link is what? 1000. So now it's replacing 0600 is 1000. So one after 1000 it's start pointing here. So once again, while condition check 1000 is not equal to null, condition satisfied and print the data percentage temp to data. So temp to data is 10. So 10 is printed, and once again temp equals to temp to link, that becomes temp to link is 2000. So 2000 stores here and starts 2000 starts pointing here. So here once again data printed 20, and 20 after printed our temp is equals to temp to link. Temp to link means what? 3000. So 3000 stores here, and after storing this 3000 it's start pointing here. So once again it's printed 30, and once again temp equals to temp to link. So temp to link is equals the 4000. So 4000 stores here and start pointing here. So and once again printed 40, data is 40. So now condition check temp equals to temp to link. So temp to link, see this, I have I have declared all that function, implement all that function within a program. So I have declared header file and struct type node, and inside that we have to declare one is data part, one variable is for data part and another for link part, and this is for globally declaration head is. And now calling simply that or whatever function we have discussed, that function call here, that function is its declaration part I have also commented here. So I do not go in details. So see how. So inside our main function is started from here, and inside that main function I have declared one integer type ch variable. So and simply calling while one. You know better why I have used here, because of we want to run our program at infinity time, unlimited time. So that's why we are passing as a parameter one. So simply write a statement to user: one for create a node, second for add at beginning, third for add after, fourth for add at end, and fifth for delete first node, deletes after, then delete last node, and 8 for length of linked list, 9 for quit from program. And simply give a print a message to user: enter your choice. What in given this choice, user what want to enter. So if you user want enter like 1 to 9 value, then according to enter that value, it's called that function. So in how it's calling, we have to use switch function passing a parameter ch variable. So first case I have case 1 create function call, and also as well as a display function. Case 2 add at beginning and as well as display function, and also case 3 add after, then add at end, then delete first, then delete after, then delete last. And similarly everywhere we are calling like display function, because of you also see in the during run whenever I run this program after compile, then you can observe. So it a length function is called, and in that simply after case 9 we have is simply to exist function, and default by default it is printed like invalid key entered, please enter a valid key. And all these function, these all function definition part. So whatever I have discussed, so that all things are implemented here. So simply I compile it and run it and show you how it's working. See this, these all function definition part are implemented here. So after displaying function, it's over. So simply I compile it first. So see, after compilation, it's throw an error or not. So it's nothing throwing an error. So simply run first. I run it. So simply I want to enter some another value 10. So see what, see this invalid key enter, please enter valid key. So now I want to call length function. So what's happened? Simply, so linked list is empty, the length of linked list is 0. Now I want to call create a node. So now 20 is entered. So now I want to add at beginning. So second beginning function is called. So now I want to enter some like 10. So first 10 is entered first. So 10 20. So now I want to call add at last. So last function add at end function called, and some value like entered size, suppose 40. So 40 is entered. See, now I want to call add after function. So third, so now which location, it's asking on which location I want to add. So suppose I want to add third location. So see what are the value. So 35 I have entered. So see 10 20 35 40. So I want to delete first linked. So what's happened? So see, I have to call fifth choice. So it's deleted 10. Now I want to delete now suppose I want to once again add at end. So once again I called fourth choice. So what's happened? I want to here add like 10. So see, 10 is added. Now I want to delete after function call. So 6 choice, and I want to delete 35, that is second choice. So our location is second. So see, 35 is deleted. Now we having 20 40 and 10. So now I want to delete last node, that is 10. So simply I have to call say 7 choice. So it's deleted. Now I want to delete this, I want to length function call. So say I 8 choice. So see this, the length of linked list is 2. Here slash, if in our program there is any slash, less number of slash, and that's why it's simply running. So our everything is whatever logic I have used in our program, that every logic is correct. So that's why it's giving correct output. So now I want to quit from program. So now 9 is entered. So quitted. So these are the implementation part of singly linked list. If you having any question, then please comment in the comment box, and if really this video is helpful to you, then please share with your friends and subscribe my channel. So thank you for watching and listening my presentation. So